everyone, so I just got done watching the video that described kind of the history of the sun, and so I'm ready to talk about how it can kind of impact our history as humans on this planet and, our development of life through that. So, as we start, we learn how the sun is really a star. It's very similar to stars, except obviously it appears brighter to us. And this is because it's a lot larger than most of the stars we can see. It's actually about within the top 10% size-wise. And then another thing that impacts it is that it's a lot closer to us. So that's why it appears both brighter and larger compared to other stars to Earth, compared to what we can see in the night sky. So some stats real quick about the sun. It's about 100 times Earth diameter. It is made mostly of hydrogen gas. And the core is pretty thick due to this hydrogen formation at the temperature that it's at. So while it's at this really high temperature, basically what happens is hydrogen fuses together and this creates helium. And then during this process, gas or energy is actually released, and energy is released in the form of light. So this is the energy that we can see from the star, what enables it to see for us to see it as a sun and create all that light for us as a planet. So it's kind of estimated that this light takes 100 or 200,000 years to be able to be seen by us. And this energy, basically what happens is, every time it encounters a particle within the core of the sun, trying to make its way out of the sun into space to be able to travel to our planet, it's losing a little bit of energy. So that's not as strong as from the center of the sun what it would be. So this energy takes a really long time to get to us, so long in fact that the sun, or the light that we see from the sun now, basically was the sun, the energy that was given off when human beings were kind of forming as species in Africa. So it's from a very, very long time ago when we were just getting our bearings as creatures on this earth, which is really interesting. Another thing that's really important is that this energy comes from that side reaction of hydrogen turning into helium, what's kind of given off in that product. And that's actually 5 million tons are converted to energy every second. So it's a huge amount of energy that's coming to us, and that's why it appears so bright to our eyes. Another thing to think about is the Earth. We can feel its heat when we're outside, in tropical places, especially when, it's not very cloudy. We're near the equator, the UV index is really high, and the Earth is 150 million kilometers away. So one thing that creates this huge amount of heat is the energy that's being produced. But again, as we talked about, this energy came from a really long time ago, but it's just reaching us now. We also learned about kind of the layers of the sun. I'm not going to go through all of it because obviously we've read about that before. But I think some things that are really interesting to note is the photosphere kind of acts as a cooling zone. And this lets the energy from the inside of the sun, what's tight in the core of the sun, kind of come out before it gets to space. It's cooled a little bit. And then also something to note is the corona, which is almost like the sun's surface, but we can call it the sun's surface, but it's not exactly because it's a little bit different in its makeup from the core of the sun. But it's so thin it can only be seen during an eclipse, or if you have the proper equipment to kind of dim the sun, because when we're just looking at it, it appears as so bright to us that we are unable to see the corona. Something else to know is really that the sun is kind of like a ball of plasma that has a magnetic field around it. These magnetic fields can kind of create loops a little bit when they get caught up within each other, and then they can get tangled. And this is really important because this can lead to flares and CMEs. And this is something that can greatly impact our society. So basically, if one of these tangled up magnetic lines erupts, we can get debris from this event that can come and hit Earth if it's kind of pointed in the right direction of Earth. And sometimes, if it's not that big of an eruption, our atmosphere can kind of take care of that, or our magnetic field may be able to cancel out most of the debris, and then just a tiny bit will come through, and this was what we would get as the aurora, or the glowing light you can see at the pole. But in certain events, this might not cancel out all the debris if it's a very large eruption, and this can lead to blackouts that people may experience, and it can really kind of destroy our modern day civilization, which is really important to note because we haven't had one of these huge eruptions kind of directed at us yet. But if it were to happen, it could impact all of our technology, and then it would take a really long time to come back from that if all of our satellites are destroyed. We could have basically all of our cell service destroyed, so everything that makes us what we call a modern day society, that could kind of be ripped by us, ripped from us in like a second by the sun, which is crazy to think, but it's something that's true. So it kind of is something we should think about for our future development as a society, and if there's, a way we can study this more to further understand it, to kind of combat a solution to it. But yeah, I'm excited to see what you guys think about it.